This is the part 2, why we can't see inside the solid. And in the part 1 there was a lots of mathematics and we explained it in terms of mathematics, but here I'll explain it in total physical way. So just we will use physics only. So when I'll keep it very brief, I'll not go in much details. So how a wave may oscillate? It may oscillate in different modes, like let's say it may oscillate like this, and this is the length of the crystal, that is L. These are the atoms. The interatomic separation is A. So when the wave will oscillate, so that means the atoms is oscillating like this. Okay, so what will be the wavelength lambda in this case? It will be simply lambda equals to 2L. How I got lambda equals to 2L? Because a complete wave looks like this. This is lambda and the half portion is lambda by 2. So this is lambda by 2 equals to L. So lambda equals 2L. Now the wave may oscillate like in this mode also. These are the atoms oscillating. In this case lambda will be 2L by 2. The oscillation may be in the oscillation may be this type. It is lambda equals to 2L by 3, and the highest mode will be this type, that is lambda equals to twice L by N. Now interatomic separation is A, and let's say there are N atoms, so N into A equals to what? L. If you look, when the modes are increasing, this lambda value, it is decreasing. It is highest 2L, then it is 2L by 2, it decreases. It decreases more in this mode, and it is minimum in this case, lambda equals to 2L by N. And if I put, so this is the minimum lambda, if I put L equals to NA, it will be simply equals to 2A. And previously I already explained that lambda equals to 2A is the minimum wavelength that can travel inside a solid. And already this wave is having the highest mode, that is इसके ऊपर तो और mode नहीं मिल सकता ना. This is having the n modes, and corresponding lambda is 2L by n, or lambda is 2A. And if you look at this mode microscopically, that is if you zoom into it, just like there are multiple atoms, and if you just zoom into it, it will look like there is one atom, here is one atom is here, one atom is here. No, here there will be no atom. It will look like this. Yes, it will look like this. If you zoom into this mode, this portion, so here is one atom, here is another atom, and and there will be another and this atom will be here. So what is the wavelength? So this is the lambda. So this is a wavelength lambda equals to 2A. And see, minimum I need 3 atoms to make a wave, and if you take 3 atoms, interatomic separation is A. So if you look, there are 3 atoms and interatomic separation is A and A, so it will be lambda equal to 2A. You may think if I take 2 atoms, so with 2 atoms you can only form a straight line, you can't form a wave. So lambda will be 2A, and to form a wave you need minimum 3 atoms, and when you take 3 atoms, this lambda will be 2A. So that again explains why lambda less than 2A wave can travel inside the solid, and corresponding to lambda less than 2A, if you look at the example of previous video, you can find that visible frequency, that is 10 to the power 15 Hz, is not allowed inside a solid.